Dear students, welcome back. Today we have three topics: hyperbolic derivatives, hyperbolic integrals and hanging cables. We want to use hyperbolic functions to understand the equation of hanging cables. So first let us try to understand how can we differentiate hyperbolic functions. And to differentiate hyperbolic functions, you need to again try to memorize these identities. The first one is derivative of sine hyperbolic x is equal cosine hyperbolic x. It's like same. We know for the normal trigonometric functions, we know derivative of sine x equal cos x, derivative of cos x equal sine x, tan x sec square x, cot x minus square x, sec x tan x, sec x, derivative of sec x tan x, but here you have negative sign, and derivative of cosec x equal minus cosec x cot x. So it's like same what we know before. However, the formula for hyperbolic integrals, formula 1 will become, since we know integration is the inverse process of differentiation, so inversely if you integrate cos hyperbolic x, your answer will be sine hyperbolic x, and you must need to add integrating constant c. And for the second one, integration of sine hyperbolic x is equal cos hyperbolic x plus c. For the fourth one, integration of cosec hyperbolic square x is equal minus cot hyperbolic x plus integrating constant c. And for the fifth one, integration of sec x tan x, sec hyperbolic x tan hyperbolic x is equal, this minus you can take here, so minus sec hyperbolic x plus c. For the last one, integration of cosec hyperbolic x cot hyperbolic x dx is equal, negative sign will come here, negative cosec hyperbolic x plus c. And you can prove this formula. Let us try to prove the first one. Left hand side, derivative of sine hyperbolic x is equal derivative of e to the power x minus e to the power minus x by 2. We know by definition sine hyperbolic x equal e to the power x plus e to the power minus x by 2, which is equal half, and derivative of e to the power x minus half derivative of e to the power negative x, which is equal half e to the power x, since derivative of e to the power x equal to the power x, and this minus will be plus because e to the power negative x equal negative e to the power minus x, which is equal e to the power x plus e to the power minus x by 2, which is equal cos hyperbolic x by definition. And this is the right hand side of formula 1. So you see derivative of sine hyperbolic x equal cosine hyperbolic x, and similarly you can prove formula 2. And let me prove the third one. Left hand side, derivative of tan hyperbolic x, which is equal derivative of sine hyperbolic x divided by cosine hyperbolic of x, and we know the derivative for the u by v is equal b square cos hyperbolic square x, and the derivative in the numerator will start from cos hyperbolic x times derivative of sine hyperbolic x minus sine hyperbolic x times derivative of cosine hyperbolic x, and this equal cosine hyperbolic x times derivative of sine. We know sine hyperbolic x equal cosine hyperbolic x minus sine hyperbolic x times derivative of cosine x equal sine hyperbolic x by using formula 1 and 2. This equal cos hyperbolic square x minus sine hyperbolic square x divided by cos hyperbolic square x, which is equal 1. By definition, we know from the identity, trigonometric identity of hyperbolic function, we know cos hyperbolic square x minus sine hyperbolic x equal to 1. So derivative of 10x equal 1 by cos hyperbolic square x, which is sec hyperbolic square x, which is our right side of formula 3. So this is how you can try to prove other formula if you are interested. So now let us try to differentiate some hyperbolic functions. For example, let's try to do it. First, derivative of cos hyperbolic x square. You see, derivative of cos hyperbolic x equals sine hyperbolic x. So we can write sine hyperbolic x square. But since instead of x, here you have x squared, so you need to differentiate x square again by using chain rule, which is equal 2x sine hyperbolic x square. So this is the answer. And for the second one, derivative of ln 10x. We know derivative of ln x equal 1 by x. So 1 by 10x. But here you have 10x instead of x. So you need to differentiate again 10x with respect to x. Let's write here 10 hyperbolic x. So it should be 10 hyperbolic x, and which is equal 1 by 10 hyperbolic x, and derivative of 10 hyperbolic x equals sec square sec hyperbolic square x, which is equal sec hyperbolic square x divided by 10 hyperbolic x. So this is your answer. And how about the third one? Derivative of sine hyperbolic 4x minus 8. We know derivative of sine x equal cos x. So this one will be cos hyperbolic 4x minus 8, and you need to again differentiate 4x minus 8, which is equal 4 cos hyperbolic 4x minus 8. And how about the next one, which is equal like x to the power n, derivative of x to the power n equal n x to the power n minus 1. So we should write 3 sine hyperbolic 3 minus 1 to 2x. So by using chain rule, you need to differentiate sine hyperbolic 2x again. Since instead of x you have sine hyperbolic 2x, so this equal 3 sine hyperbolic square 2x, and derivative of sine hyperbolic x equal cosine hyperbolic 2x times derivative of 2x, this equal 3 sine hyperbolic square 2x cos hyperbolic 2x times 2. Derivative of 2x equal to 2, so I should write here 6. So this is the answer, which is equal derivative of sine hyperbolic x. It's like cos hyperbolic x, cos hyperbolic cos 3x. But since instead of x you are using cos 3x, so you need to differentiate cos 3x again, which is equal cos hyperbolic cos 3x times derivative of cos x equal minus sine 3x and derivative of 3x again 3. So the answer will be minus 3 sine 3x cos hyperbolic cos 3x. This is the answer. So now let us try to integrate some hyperbolic functions. For example, in A, integration of sine hyperbolic 3x cos hyperbolic x dx. We can integrate it by the method of substitution. If you say, let's say sine hyperbolic x equals z, therefore cos hyperbolic x dx equal dz. So this integral becomes z3 dz, which is equal z to the power 4 by 4 plus integrating constant c, and now you can substitute z here, sine hyperbolic 4x divided by 4 plus c. So this is the answer of B. A. How about B? This one you can write sine hyperbolic x by cos hyperbolic x dx, and since the derivative of cos hyperbolic x equals sine hyperbolic x, so you can write ln absolute value of cos hyperbolic x plus c. This is the answer of B. So let's say 2x minus 3 equal another variable z, therefore 2 dx equal dz, then dx equal dz by 2. So which is equal cos hyperbolic z dz by 2, which is equal half cos hyperbolic z dz, and which is equal half, and integration of cos hyperbolic z is equal sine hyperbolic z, and z equal 2x minus 3 plus c. So this is the answer. So how can we integrate it? Let's consider this one as indefinite integral. So 10 hyperbolic x sec hyperbolic square x dx. Let us consider sec hyperbolic x equals z, then minus sec hyperbolic x 10 hyperbolic x dx equal dz, therefore sec hyperbolic x 10 hyperbolic x dx equal minus dz. So this integral becomes sec hyperbolic square x times sec hyperbolic x 10 hyperbolic x dx, which is equal z square minus dz, which is equal minus z to the power 3 by 3 plus integrating constant c. Now you can put your z here, sec hyperbolic 3x by 3 plus c. So for the definite one, this result now becomes minus 1 by 3 sec hyperbolic 3x. You don't need to use integrating constant here, ln 3 ln 2, which is equal minus 1 by 3 sec hyperbolic 3 ln 3 minus sec hyperbolic 3 ln 2. We can put your answer here, and since we know sin hyperbolic x equal e to the power x minus e to the power minus x by 2, so numerator we can replace e to the power x minus e to the power minus x equal 2 sin hyperbolic x, and the denominator will also be 2 cos hyperbolic x dx. We can cancel this and this, and since the derivative of cos hyperbolic x equal sin hyperbolic x, so now we can use this formula, integration of this equal ln cos hyperbolic x 0 to ln 3, and ln cos x is an even function, so we don't need to use absolute sign here because this one is positive. This equal ln cos hyperbolic x equal e to the power x plus e to the power minus x divided by 2, 0 to ln 3. So now let us put the upper limit. You will get ln e to the power ln 3. You see, e to the power ln 3 equal 3, and e to the power ln minus ln 3 is equal e to the power ln 1/3, which is equal 1 by 3. So if you replace ln 3 here, you will get 3 plus 1 by 3 divided by 2 minus, now if you put lower limit, e to the power 0 is equal 1 plus e to the power 0 equal 1. So 1 plus 1 divided by 2, ln 2 divided by 2. So now this equal ln, you see, 3 plus 10 plus 1 by 3. So 10 by 3 times 1/2 minus ln 1, 2 by 2 equal 1, which is equal ln 5 by 3. This is the answer, since ln 1 equals 0. So let's try to understand our third topic, and this is the last topic in this lecture, which is hanging cables. So you see, when a homogeneous and flexible cable is suspended between two same height pole or points, between two same height points as a telephone line hanging between two poles, such a cable form a curve which is called catenary. And this word comes from the Latin word catena, which means chain. So it's look like a chain. So this cable has an standard equation which you can represent by the help of hyperbolic functions, and the equation of this cable is y equal a cos hyperbolic x by a plus c, and here A and C are parameters. The values of A and C depends on the distance between two poles, and it also depends the composition of the wire or the materials of the wire. So this is the standard equation of a catenary. So you must need to remember this formula. Standard equation of a catenary is y equal a cos hyperbolic x by a plus c. Now let us try to use equation of catenary in order to solve some real problems. For example, let's look here. A 100 feet wire is attached at its ends to the tops of two 50 feet poles that are positioned 90 feet apart. The question is, how high above the ground is the middle of the wire? So it says a 100 feet wire. The question tells us the length of this wire is 100 feet. This is the length, and attached ends of 50 feet up to 50 feet poles. So the height of this pole is 50 feet and this one also 50 feet, and they are positioned 90 feet apart. So that's the reason this one is the origin. From here to here it is 45 feet and this one 45. So that they are positioned into 90 feet apart. The question is how high above the ground the middle of the wire. This is the middle of the wire. So what is this height? That what we need to calculate. And we know the equation of catenary is the equation of is y as a function of x is a cos hyperbolic x by a plus c. Let's say this one equation number 1, and this question tells us y 45 is equal a cos hyperbolic 45 by a plus c, and which is equal 50, since y 45 is equal 50 and y minus 45 also 50. So we have another equation, let's say equation number 2, and we need to calculate what is the value of y at 0. So the middle of the wire is at 0. When x equal to 0, what is y? That's what we need to calculate. And when x equal 0, y0 equal a cos 0, and a cos 0 means 1. So a plus c. This is equation number 3. So finally we need to calculate a and c. Now by the arc length formula, you know the length of a curve is known as arc length, and there is a formula. We know arc length L equal integration from a to b 1 plus dy by dx whole square root dx, and here we are given L equal 100 feet. So I should write here 100 is equal, and the lower limit of this integral, the two end points of this curve is minus 45 and 45. So the lower limit will be minus 45 and the upper limit 45, which is equal 1 plus y is this. So the derivative of y equal, so it is sine hyperbolic x by a, sine hyperbolic square x by a dy by dx whole square dx. That implies 100 equal minus 45 to 45, instead of this I can write 2 times 0 to 45, because this length and this length are same. Square root of 1 plus sine square x by a is equal cos square x by a. So cos hyperbolic square x by a dx. I can cancel this square root and this 2, which is equal to 0 to 45 cos hyperbolic x by a dx. And I can also cancel this 2 and this 100. So this one implies 50 equal integration of cos hyperbolic x by a, which is equal sin hyperbolic x by a divided by derivative of this, which is equal 1 by a, 0 to 45. This equal a sin hyperbolic 45 by a, because sin 0 equals 0. So this implies 50 equal a sin hyperbolic 45 by a. And this equation you cannot solve by using your hand. So by calculating utility you can solve it, and the answer will be a is approximate to 56.01. We know a and c. We already get a. Now how can we calculate c? C we can calculate from equation 2. We have 50 equal, I can replace a, 56.01 cos hyperbolic 45 by 56.01 plus c. This implies c equal 50 minus 56.01 cos hyperbolic 45 by 56.01, and you can calculate it by using your calculator, which will be c will be approximate to minus 25.08. So now you can use a and c in equation 3. Equation 3 was y0 equal a plus c, which is equal a equal 56.01 and c equal minus 25.08, which is equal 30.93 feet. So this is the answer. So the middle of the wire is 30.93 above from the ground, and that's the end of this talk. And you can try some homework in your apartment, and these are the homeworks. That's the end. Thank you very much, and hope you will see my lecture 8. Stay connected with us, and hope you